This is chapter 11.1, which is dealing with ratios and proportions. Before I begin this, and just to kind of give you an overlook on where we're going and where we have been, we just came out of the chapter that was dealing with reviewing adding, subtracting, multiplying, and dividing fractions, as well as solving equations that happen to have fractions in them. So we looked at all of those and reviewed all of those kinds of operations with fractions. 11.1 is just dealing with ratios and proportions. Here are our objectives for this lesson. Number one is to analyze three different methods for solving proportions. I am going to, however, focus on one, which is called cross multiplication. That's pretty flaw-proof, so we're going to be looking at that in most detail. Number two, you're going to review the basic steps in solving equations. What you're going to see is we're going to, in this process of cross multiplication, we're going to be setting ourselves up with the equations that we need to solve. So we're going to need to review those steps. 3. Understand how things in life can grow proportionally. There's a lot of things in life that are proportional. There's a lot of scenarios and situations that are theoretically proportional. So we want to look and kind of examine those. What I am going to start you off with is a video. We're going to look at YouTube, and this was a video that was posted online. So here's the link to that if you want to look there. However, I'm going to show you this quick, it's like 1.5 minutes.
The Hubble Space Telescope is our eye in the sky, and it has delivered some stunning images. The inner workings of the Hubble include a network of mirrors and lenses. A lens refracts light and focuses it on a point to form an image. There are three variables that are of importance with any lens. First, there is the focal length of the lens. This is the point in space where a lens brings an image into focus. The focal length is usually described with the letter f. The second variable is the object distance, in other words, the distance between the lens and the object you are looking at through the lens. The object distance is usually described with the letter O. The third variable is the image distance. This is where the refracted light from the lens produces an image of the object. The image distance is usually described with the letter I. This equation describes the relationship among f, O, and I.
Alright, so the point of showing that video is that is where we're going with this chapter. Just like we have had in the past for the last two chapters, these fairly major projects at the end of each. So we had the cell phone project, we also had the bathroom project just recently, and now we're going to be having this focal point and lens project, as well as we're going to be looking at business models. So for anyone that's maybe interested in business, and also anyone that's interested in kind of some physical sciences, those two applications we're going to be turning into projects at the end of this unit. So the thing is, just as what we have had in the past with those projects, if you are not learning the skills as we go along through these videos or these lessons, if you are not practicing the homework problems, you probably are not going to achieve these skills, and as a result that's going to show in the project. You're going to struggle through the project. So you need to be on board with these videos, keep on top of these lessons, and you'll be successful with that project in the end as you're trying to apply the skills. Same thing with the test, and as you know, the tests are always very much related to the projects that we have. Alright, so we're going to start out with the basic. We're going to start out with the vocabulary of this section. There's going to be more to come, but these are the two major ones. Here are ratios and rates. This is going to be the comparison of two quantities using division. And of course, here is an example, and what do you know? It looks like our good old fractions that we've been working with. So go ahead and write that down. You can pause me if you need to so that you can get it down. Don't forget there can be stories behind this, okay? This could be read 1 to 2, okay? Or it could be 1 out of 2. You can put a story behind this. So for example, you could maybe be looking at the quantities of how many apples Joe can eat compared to how many apples Sarah can eat. So it's going to be 1 to 2 one apple to two apples, and Sarah is the one that's going to be able to eat more apples. You could also look at this as 1 out of 2. So maybe you could say 1 out of 2 people have a dog or something like that. So don't forget these fractions. Sometimes they look a little boring at first, but there can be stories behind it. Proportions, rates that are equal to each other. So that's when you're going to actually be setting or some sort of rate, so here is our rate, equal to another. So you can try to come up with an equivalent fraction to do it. So for example, 4 out of 8 would be equivalent. Here I have a visual of solving proportions or looking at what proportions are. So here what we have is two quantities. Alright, it's going to be a person to candy or candy to person. It's up to you. But I am, being the nice person that I am bringing giant pieces of candy for the student that I expect to see that morning. So a person came in for help because that's a wonderful thing to do. And in that morning I knew that person was coming, so I brought these body-sized pieces of candy to that person. So I'm going to go ahead and set up the quantities of the number of candies over the number of people. So here I have people quantity and candy quantity. So I'm going to set up the rate, which is going to be 3 to 1, or 3 to 1, or 3 over 1, however you want to say it. So there is my rate. What would not be right, is if I were to go and say 3 over 1 is fair or is the same thing as if I were to up the number of people, okay, and just keep the number of pieces of candy the same. So here's one student that came in the morning, and here's one student that came in the morning, and I'm just going to leave it. So sorry, student number 2, you don't get any candy, but my student number 1 does. Okay, or what if another student comes in? The ratio would not be equivalent. These are not the same rates. So I have 3 to 1 and nothing for these guys. So what I am going to say is you need to make sure and keep it fair. So what we're saying here is if you do want to find something that's proportional, I'm going to change this to 3 now. So I have 3 students. How many pieces of candy will I need in order to keep this the same rate throughout? Well, keep in mind that if you multiply the bottom by something, you've got to multiply the top. If you divided the bottom by something, you have to divide the top. So when you're looking at this, what's 3 over 3? Well, that's just 1. So I've taken my rate, which was 3 over 1, times 1, which doesn't change it at all. However, the look does change a bit. Now we have 9 to 3. Okay. Same thing as if I were to take 3 to 1 and I were to change this to 4 people. Yeah, so if we change it to 4 people, I'm going to bring in another person here, but remember, I'm being fair. I'm going to bring in 3 more pieces of candy. So this is proportionally growing. You can see both quantities, top and bottom, are growing. So this is going to be 12 total. I'm going to ask you now, what if I had 12 to 4, okay, and I wanted to say there's 28 students, okay, and I didn't know how many pieces of candy that I wanted. So I am going to write a proportion now, and I'm going to need to solve it. What I'm going to share with you now are the 3 different methods or 3 different ways of solving proportions. The first one, we're going to look at that kind of briefly. If you were looking at this proportion here, I have 12 over 4 is equal to x over 28. And what you do want to realize is that you can always, when you're solving for something, solving for equations, solving proportions, what you want to find out or know is your unknown. So we have this variable that represents some sort of value which we don't know, but we want to solve. So what you could do is see that, well, x is being divided by 28. I don't want to know what x divided by 28 is. I just want to know what x is. So undo this operation of division by multiplying 28 to both sides. Okay, 28 over 1 is what 28 is. So you can see how these are going to cancel each other out. But in order to maintain this equality, whatever you do to one side, you got to do to the other. So I'm going to write that as well on that side. So now you just need to see, okay, 28 and 4, they have something in common, 4. 4 itself will divide 28 and 4. So when you do 28 divided by 4, you're going to get 7 times, so 7 over 1, times 12 over and then 4 divided by 4 is 1, equals, over here we just got our 1x like we were hoping for. So now you just have to multiply these, and you're going to get x is equal to, when you type that in, you're going to get 84. Okay, so you just solve for your x by using algebra. Alright, we also have another method, method number 2. It's the use of equivalent fractions. So once again, if you were looking at a proportion such as this, remember we have 12 pieces of candy for 4 students. How many do we have for 28? Well, equivalent fractions, keep in mind, is when you're saying, I can find an equivalent fraction as long as I do whatever I do to the bottom to the top as well. So if you multiply the bottom by some number, you got to multiply the top by that very same number. And you will maintain the equality. So I'm going to go ahead and say, well, 4 times what is 28? 4 times 7 is 28. So whatever you do to the bottom, you're going to do to the top as well. So here, what you have done is you have taken this term 12/4 and you have multiplied it by 1. So have you changed this at all? No, you have not. So 7 over 7 is just 1, keep that in mind, is equal to what? And this is where you're going to get 28 on the bottom, but that x, that unknown that was on the top, is now known as just 12 times 7, which is going to be, once again, 84. Okay, so there, once again, you got x is equal to 84. This third one, I'm going to go into more detail. This is the one that I would prefer that you use in this assignment for the most part. When you're going through problems, sometimes you can just go ahead and use what you're comfortable with. These you have kind of been working with. This one's maybe a little bit new. So here we're going to look at some vocab. So here's your vocabulary for cross products, first of all, to know what they are. So we're going to use the idea of cross products to help us solve these proportions, but first of all you need to know that they are the numbers that are kind of opposite of each other in these ratios, or in these proportions. This should be a proportion. Sorry. So when you have a proportion, so these two ratios set equal to each other, you're going to be looking for literally the cross numbers. So these right here, these are cross numbers, and the product, don't forget, is when you multiply. So 2 times 21, that's a cross product. Another cross product that exists here are these two numbers. These two numbers are across from each other, and then so therefore 3 times 14, that is going to be a cross product as well. What you're going to notice about any kind of proportion that's a true proportion is when you multiply these, 2 times 21 is 42, 3 times 14 is 42. You can do these for all proportions that you could possibly think of. Okay, and what you're going to find is each time when you multiply those cross numbers, 2 times 4, 8 times 1, what you're going to see is they are equal to each other. Okay, so here is a property that I do want you to write down, put a big old star by it if you need to. Cross products of proportions are equal. And we're going to use this idea to now solve equations. So these are all where you're going to get your notes from. Tune into the next video in order to get examples that are straight off of your homework.